Good evening. Welcome to Ask the Lady Electrical Inspector podcast. I am your host, Tabitha L. Tonight, I will conclude this series with frequent reasons why commercial electrical inspections fail. Last week, I ended with lashings of the service conductors inside of the switchgear. So I just wanted to give a recap on what the lashing was used for. Is strapping up the cables inside of the switchgear, making sure that if anything happens, that the cables won't violently move about inside that gear. So with that being said, I'll move to another issue that I find on quite a few jobs when you're in the bottom of the switchgear. Because now we're still talking about service conductors and service equipment and why they fail inspections. So we're in the bottom of the gear, and the code says that you can only have a maximum of 3 inches of raceway inside of the gear. So that's a problem that I see often. Now, they may have somewhere between 4 inches, but the code states that it should be a minimum of 3. So just try to keep that down, because if you go over 4, I will make you do something to correct that. But just make sure you try to keep it under 3. And also make sure that if you do cut around that raceway, that you ream the inside and you clean out the shavings to make sure that it's a nice smooth cut. Okay, so remember the 3 inches or less. So we're still inside of the switch gears. And another issue that I have on a regular basis when I'm doing these type of inspections is the switch gear. It has the main bonding jumper inside of the switch gear. It has to be connected to the panel board. And all sections of the switch gear shall be bonded together using that main bonding jumper. So when I'm doing these type of inspections and I'm looking for that jumper, most of the time I'll find it wrapped up still in the saran wrap in the bottom of the switch gear, or sometimes I'll find it with a bolt just dangling on to the side, but it's missed a lot. So when you're doing that main switch gear, make sure that that's something that you read the instructions on, and make sure that you connect that bonding scrap and to the gear, to the neutral bar, because that's the importance of it. Like, all sections of the switch gear must be bonded together. So that's something that's often forgotten. So I just want to remind the electrical contractors that that's something that needs to be remembered. So now remember, we're still at the switch gear, and I'm there to do electrical inspection, to call in the switch gear or your electrical service. I'm there to make sure you can energize it and send it to the utility company. So one of the things that I have often failed the inspection for is the labeling. Now I'm there to do the inspection, to send it in, and it has to be labeled, because they have to know what they're looking for when they come there to energize that service. The utility company, it needs to be labeled. So most of the time the contractors will say, well, that's on the way, it's not here right now, but that's something that needs to be addressed before you call in that inspection. So now we're still at the switch gear, and this is something that I mentioned earlier when you have the multiple services. So if you have multiple services like 3,000 amps, 2,000 amps, 600 amps, so you have multiple services. So now you have to bond your switch gear, and that bonding means that it has to be bonded by every available means that's on that premise. So the main bonding methods that are required inside that switchgear would be the bonding of the main water, the water grounding, the water. That's one of the mains. And then the other bonding for that system would be you got the water, and then you have, well, the point I'm trying to make here is that you have to bond your water, your switchgear inside you have to bond your switchgear service. So each service has to have a grounding electrode. So the point I want to make here is that if this is a new construction job, you're most likely going to have building steel. So with that being said, with the bonding electrode conductors, you can use that solid beam. You have to prove that it's a solid beam. It has to go back by the main water grounding electrode, the main water, because you're using that beam as a grounding electrode conductor. So when you're using that beam, if you have 4 services, you're going to tap off of that beam 4 times. Now remember, the highest, the most that it's allowed in my jurisdiction, a 3-aught copper or 250 aluminum. So if you're going to use that beam, you have to use the maximum. So a 3-aught copper or 250 aluminum. So if you got a 2,000 amp switchgear, you got 3,000 amp switchgear, 2 600 amp switchgears, you can tap off of that 4 times and go to each one to the bottom of the gear and terminate there first, because that's your first means of disconnect. Now, with this beam, there comes requirements that when you're using building steel or building frame can be used as a grounding electrode if it satisfies specific electrical code requirements, such as I stated, being continuous and electrically continuous and having a resistance to ground that is below the predetermined limitations. And what I was going to mention is the rust. You have to remove the paint or the rust from the steel. So most of the time what we do is take a grinder and grind that rust or that paint off of there, and then you make your connection. So that's something that needs to be taken into consideration when you're running your grounding electrode conductors. So remember, now you can use the steel, the building steel, but when you tap it, you have to tap it and go into the switchgear with a 3-aught, the largest conductor, because you oversizing and overcompensating for that beam. And then at the other end of the water, now you have to come down 4 times as well, because you have 4 services. So you're going to be on that main water, incoming water line valve 4 times. So just keep that in mind. That's something that can come in handy. So I'll move on. So I just wanted to touch again on the double the working clearance, because that's an issue that I have on most of my new construction jobs. When I go there, that's the first thing I want to see is the electrical room. I'm not going to go too deep into that because I mentioned it several times, but just make sure you check clearance. Like if you make sure you're checking your gear, you check that with Article 11026, that table, to make sure you're just meeting those requirements. Just make sure that those are being met. So I've had this maybe about 3 weeks ago with the cable tray. The cable tray being used for service conductors. Now, that's not something that I often see a lot of, but it is allowed, but it's certain conditions that's allowed in as well. because normally you don't use it because once you enter the building, it has to terminate at the readily accessible location. So with this being said, this the conductors just came right into from the outside, and I really don't know why they use service tray, but that's what it was spec'd out for. So that's not a problem, but the issue that was the issue for this inspection was that when they made offsets and bends and they deteriorated the tray or broke the tray, the bends, the metal parts. So now they broke the integrity of the tray. So now you have to bond those pieces back together. So that was the issue with those. And the tray has to bond to the switchgear as well. So that was the issue with the service tray. I don't have that one often, but I just thought I'll just put that out there because that was an issue about 3 weeks ago. So I'm going to move on to bonding bushings. I have this quite often, the bonding bushings. So if you're using a metal raceway and you're in a concentric knockout in a meter can and you're using a metal raceway and it's not knocked out all the way to the 4-inch hole, you have to use a concentric, it's a concentric knockout, so now you have to use a bonding bushing or a bonding screw or something to bond the can to make sure that integrity is not broken. So just remember, if you're using a metal raceway and a concentric knockout, you need a bonding bushing. So I have had this question asked many times before on the jobs, the new construction jobs. Can you bond a gas pipe, a gas line to the electrical system? No. Even the code states that you cannot bond a gas line to the electrical system. Now, I have seen on the plans where it does state that it has to be bonded to metal or some type of metal structure in that building, but not to the electrical system. Even if you run your own grounding, if you run your own supplementary ground rod outside and ground your gas pipe to that, it's not bonded to the electrical system. So just keep that in mind. It can't be bonded to the electrical system, meaning it can't go to the switchgear. It can't go to the auxiliary bar in the electrical room. It can't tap on to the electrical grounding rod if that's outside. You can't tap on to that. You can't tap on to anything in that electrical system. So I just want to mention that because I'm asked that question very often. And that's something that it seems to always go back to the engineer. And it comes back with that result that you can't do that. So one thing that I have an issue with often is when you're running the parallel conductor cables, the conductors, that you just got to keep in mind that everything has to be the same. Everything has to be the same length, the same conductor material, the same size and circular mills, installation, terminate in the same manner. So just keep that in mind, because the problem that I've had would be that the cable is longer. One phase is longer than the other phase. So that's not meeting the requirement that terminating in the same manner, and the conductors have to be the same size if C phase has more conductors than A and B. So you just have to keep that in mind when you're running the parallel conductors into the switchgear. Okay, so this is something that I've had issues with. When I come on the inspection, if I'm coming there to do an inspection to send it in to the utility company, I'm checking both sides of that equipment. So both sides have to be terminated, meaning that the meter side has to be completed and the switchgear side has to be completed. So the problem that I've had is that when I get there, the conductors are open on the switchgear side. So they're saying that the electrician is saying that they can't do anything until the utility company comes out, and they need to work together. So what that's called is a disconnect reconnect, and it's an actual form that's filled out when you have to work in conjunction like that. Because if I come out to an inspection, I can't send wiring approval in if you have open conductors. That's when you'll contact your jurisdiction, your municipality, and you'll ask for the disconnect reconnect form, and you'll need the permit number of that job. You need the person that you're contacting, the contractor name, the location of the job. You need the premise number, the owner. So there's some information that you're going to need when you fill that form out, and then it's valid for 90 days. So with that being said, the summary there is that I don't call in for inspection if you have open conductors. You don't need an inspection. You need a disconnect reconnect. So that's the statement that I want to make on that. So with that being said, to bring it to an end, I receive this question often when I am sending in these wiring approval to the utility company. I receive, how long does it take for the utility company to energize an electrical service? Well, I've been told 3 to 5 business days. If there's nothing major going on in the area and that it's just normal business operations, that it takes 3 to 5 business days. Now, once we send it in to the utility company, there's no more that we can do. But we can, after a certain amount of time, if you don't receive it, just give us a call and we'll look into it for you, and then we'll make sure that it does get sent over. So that concludes my my pointers for when the inspections fail for electrical installations. So next week, what I want to talk about, because remember, what I'm doing here is just walking you through the steps of a brand new construction job in the process. So first we started with the wall cover. Well, first we started with the ground cover. Then we started with the wall cover, the ceiling. Then we went to the temp on service. That's what we did with this 2-part series. We did the temp on service. So now the next phase in the job is when you do your temp on service to energize your electrical systems. Now you want to call for a temp OC. So I'm going to walk you through those requirements. That'll be short and sweet, but I do get a lot of questions on that, so I'm just going to give you the procedures for that. If you had any questions, that'll be something you will want to tune in for. So if you have any questions or comments, please contact me on any of my social media pages at Facebook, Instagram, X, YouTube, under the moniker Ask the Lady Electrical Inspector. If you would like to add anything to this discussion or provide feedback, you can email me at asktheladyelectricalinspector@gmail.com with any questions or electrical concerns. Thank you and good night.